In this video, we're going to work on Chapter 12 homework, problem number 17. If you'd like to follow along, open the Chapter 12 homework.xlsx workbook from My Courses and click the Problem 17 tab. So in this problem, they basically asked two questions. They want us to determine the profitability of the business, and then what is the probability that the park will incur a loss in any given season. So let's start and answer the question. So first, we're told that the number of adult tickets sold has a normal distribution with a mean of 20,000 and a standard deviation of 2,000. So in cell B4, I could put in the equals norm.inv and then open the parentheses. Remember, and for the probability, we do the rand. Then it's just going to ask for the mean, which was given, of 20,000, and the standard deviation of 2,000. But we're going to need the analytic solver because later on, for the food and beverage revenue and the souvenir revenue, we're going to need a triangular distribution. So I'm going to solve this first with the analytic solver. So I'm going to click analytic solver. It's going to come up for a second. This is the first time I've opened it today. I will close that, and we won't need the solver model until next week. So I'm going to click on cell B4, and I'm going to click distributions, make sure that I'm on common, and I'm going to choose normal. So for the normal distribution, under parameters, in mean, I'll put in 20,000, and standard deviation is 2,000. So remember, you either click away or click save to draw the distribution, and now we can click save. Now the second one that we're going to do is the children's tickets, same thing, except with a mean of 10,000 and a standard deviation of 1,000. So distributions, normal, mean, 10,000, standard deviation, 1,000. Click away to draw it, and click save. So notice we have the sign normal. So if you have the analytic solver installed, you could have also just typed sign normal. Now for the food and beverage revenue, we're supposed to use a triangular distribution. So I'm going to click distributions, make sure that I'm on common, and I'm going to choose triangular. So we're told between 50,000 and 100,000 with a most likely of 60. So again, we put in the parameters. So our minimum is going to be 50,000. Our most likely is going to be 60,000. Don't worry that it can't draw it yet. We're not finished putting in the parameters. And finally, our max is 100,000. So now I click away to draw my triangle, and I click save. Now the last one we have to enter, souvenir revenue, 20,000, 25,000, and 30,000. So I click in cell B9, distributions, triangular, minimum 20,000, most likely 25, and maximum of 30. Click save to draw, and click save again to accept it. Okay, so notice now the model is all filled in. So if we wanted to use a data table, we'd be all set, and I'm going to show you how to use the data table at the end of this, but we needed the analytic solver for the triangular distribution anyway. So anyway, to answer the two questions, the distribution of the profit and also what's the likelihood of a loss, Step 2 in using the analytic solver is to set the result cell. So because both questions were on operating profit, I'm just going to choose one result cell. But normally we could choose any of the revenues, we could choose total revenue, contribution margin, we could choose multiple result cells. So to choose a result cell, I click on it and I could just add plus psi output, open parentheses, close parentheses, but it's just a heck of a lot easier making sure that you're on that analytic solver tab to click results and then in cell, and notice how it just added the plus psi output, open parentheses, close parentheses. Now the third thing to do is to go to the options. Never forget to go to the options, but it's less important if you're running multiple simulations because you've already set it for that time. But don't forget to go to the options. So I'm going to click options. 5,000 or 10,000 would be a good number of trials. We are limited to 2,500. So I'm going to choose 2,500 and only to run one simulation. Make sure Monte Carlo is chosen. That's all we have to worry about on this dialog, and we click OK. Now that we've done the first 3 steps, we've set the distributions, set the output cell, and did the options, now the 4th step is to just run the simulation. So making sure that you're still on the Analytic Solver tab, click Simulate, and then run once. But this is not the chart that we need. Actually, this is the chart that we need. This is the chart of C22. Normally you get variable plot. But if you got a variable plot, all you'd have to do is close this, and we just double click cell C22 to get our results from the Analytic Solver. So to answer the first question, to determine the profitability, the mean is 314,000, the standard deviation is 32,000, so I would actually say that this business is actually pretty darn profitable. In fact, it doesn't even look like it goes down to a negative number on the chart. But to answer the second question, what is the probability that the park will incur a loss in any given season? So what I'm going to do is notice that red dot over there. I'm going to hover over it. That one is lower. Notice the 261 above it. That means that there 5% of the observations are below 261,000. So what I'm going to do is I'm going to click where it says 261, just type a 0 and hit enter, and just as I thought, the line completely disappears. So what we have is basically, given this, there's almost 0 probability, or actually from running this simulation there is 0 probability that this park will incur a loss. Now, let's say we wanted to solve this problem using a data table. Now, we couldn't model the food and beverage revenue or the souvenir revenue because we don't have a triangular distribution in Excel, but we do have several distributions. So, if I click Formulas, More Functions, Statistical, notice we have a binomial distribution, a beta distribution, chi-square distribution, normal distribution, gamma distribution, log normal distribution. So there are a lot of options, but unfortunately no triangular. A t-distribution is different than a triangular distribution. So I'm just going to leave those numbers as they are, but I'm going to change the formulas for B4 and B5. So in B4, I'm going to type equals norm.inv, open the parentheses. For the probability, I type RAND, open parentheses, close parentheses, comma. Mean, if you remember, was 20,000. Type a comma. And standard deviation, if you remember from the book, was 2,000. So you don't have to remember those numbers. mean and standard deviation are given. So I hit enter, and again notice every time I click calculate now, I'm going to get a different answer. Now I'm going to do the same thing for children's tickets sold. Instead of the sign normal, I'm going to type equals norm.inv. That returns a number rather than a probability. For the probability, I will type RAND, open parentheses, close parentheses, which returns a random number between 0 and 1. Type a comma. For the children's tickets, the mean was 10,000. Do not type a comma or your mean will be 10. Now I type a comma and my standard deviation is 1,000. I close up my parentheses and hit enter. Now the second step is to remove that psi output from cell C22 because we're not going to need it if we're using a data table and it's going to mess things up. So it's gone. The formula there is the original one, equals C20 minus C21. Now in cell F1 I will type the word trial, and what the heck, let's do 1,000 trials. So in cell F2 I will type the number 1. I don't want to use the fill handle to drag it down to 1,000, so I'm going to click home. In the editing group I'm going to click fill and then series. My series is going to be in columns. I can't tell you how many times I forget that and my numbers go across instead of down. It always annoys me when I forget, but we want it in the column. Step value is 1. We could do it by 5s or 10s, whatever we want, and stop value is 1,000. So I click OK, and Excel has just filled the numbers 1 to 1,000 in column F. Now in cell G1 I'm going to make reference to the formula that I want to appear in column G, which is the operating profit. So I could put the exact same formula here, type equals C20 minus C21, but that formula already exists. So in cell G1 I'm going to type equals and then click on cell C22. So that tells Excel that whatever is in C22, also the same thing belongs in G1. I hit enter. Now I select the range. F1, you have to include the headers. It doesn't take quite as long to select as you would think, and it slows down towards the end. So F1 to G1001. Now I'm going to click data. In the forecast group, I'm going to click what if analysis and data table. Now the trick here is that we don't want any numbers substituted. We just want Excel to click calculate now after every trial. So to do that, I'm going to click in the column input cell and I just click any blank cell in the document. It can be D2, D8, J3, K45, I mean whatever you want. So I'm just going to click over here cell I4 just randomly and I click OK. And now I am getting 1,000 trials of the profit, which looks very, very similar to the results that we got using the analytics solver. So if we wanted to use Excel to answer the two questions, first of all, to answer the first question, what is the distribution of profit? Basically, we want the mean and the standard deviation. So mean and standard deviation. This is what happens when you use a volatile formula. Every time you hit enter, it recalculates. Now, for the probability that it's going to be negative, we have 1,000 trials, so we'll just count the ones that are less than 0, which actually looks like it's 0. So let's count the ones that are less than 0. And let's go. So in cell J1, to calculate the mean, I will do equals average. I will open the parentheses. I'm going to click on cell G2. I'm not going to include the header. And at least my Windows users can do Control Shift and then down arrow. And I have now just selected the range G2. I'm going to scroll up, G2 to G1001, and I'm going to close up the parentheses and hit enter. So we have a mean of 315,959. Once again, very, very similar to the results we got with the analytic solver. Now in the standard deviation, I'm going to type equals STDEV, open the parentheses. Oh, I'm sorry. That's the old formula. We actually need STV.P or STDEV.P or STDEV.S. I always get confused between population and a sample, but I do believe that this is a sample, not a population. So I want to double click STDEV.S or just type STDEV.S now that I've successfully done that. And I'm going to click cell G2 and once again do that little magic Control Shift and then down arrow. And I've now chosen the same range, G2 to G1001, or you could even just type it in. So I'm going to close up the parentheses and hit enter. So we have a mean of 314, almost 315,000, and a standard deviation of 32,675. Now, let's count the numbers that are less than 0, but we already know it's going to be 0. So I'm going to do equals, so in cell J4, I will type equals COUNTIF, open the parentheses. So the range is going to be cell G2, and this one I'll scroll down instead of using that little trick for my Mac users. So it takes a moment, but it goes pretty fast and it slows down towards the end. So I have my range, I type my comma, and now for my criteria, in the quotes, type a double quote, and then less than sign 0, close up the quotes, close up the COUNTIF. Hit enter. And as predicted, I get the number 0 because they're all around high 200,000s or low 300,000s. But had I got a number other than 0 to calculate the probability, all I would have to do is take the number in cell J4 and divide by 1,000. In this case, 0 divided by 1,000 is 0%, so we could say that the mean is 314,964, standard deviation 31,801, the number under 0 is 0, and one thing that we could also do to lock this down is just type in these numbers, these latest numbers, and then what happens is this is no longer volatile, it won't change anymore. Well, I hope this helped you do your data tables.